Hello everyone, my name is Sam van Damme and I'm a PhD researcher at Ghent University and IMEC. And in this presentation I will present the content of our paper Human-centric quality management of immersive multimedia applications, which I wrote together with Maria Torres Vega and Philippe de Turk. Now I would like to start this presentation by showing you an image of which I'm sure you have all seen it before. Imagine watching a YouTube video and all of a sudden the video starts stalling, the little load icon appears and nothing happens anymore. Now, depending on your ease of mind, you can just sit back and relax and wait for the video to restart. But typically people tend to start pushing buttons, start moving the slider back and forth, refresh the page and so on. Now, this is a very easy and straightforward example of quality management that did not went as it should be. Of course, this is entertainment, so it is annoying that it happens, but not really critical. However, nowadays, more immersive multimedia with more societal and economic impact is gaining attention, especially within the light of this current COVID-19 health crisis. I'm thinking about remote education applications, about virtual training scenarios, such that someone can train a skill before actually applying it on site. Even more futuristic, telesurgery, such that a doctor can perform a surgery possibly from the other end of the world. Now, you can imagine that quality management will be a key factor in order to realize this kind of applications. Before I dive into this quality management, I would like to give you a short description of what I actually mean by immersive media. So when I talk about immersive media, I talk about the combination of sensorial channels that each mimic one of the human senses. And given the current possibilities of technology, there are actually three of them. First of all, there's the visuals, thus virtual reality in terms of 360 video or synthetic environments. Furthermore, there's 360 sound or spatial sound, like it's sometimes called. And third, haptics, thus simulation of touch, pressure, vibration, which can be in terms of the gloves shown on the slide or even a full bodysuit. And the combination of the three is what we call a multimodal system. Now, this immersive multimedia experiences pose rather stringent conditions in terms of bandwidth and latency. However, for example, small desynchronization between the different input sensory channels can lead to dizziness, and a degradation of the quality can lead to a decrease of the feeling of immersiveness and concentration of the users. And therefore, we think that the management of this quality will require to shift from the network to the human, to the end user. Now, therefore, let me first address how this loop looks like. There are actually three big parts. First of all, there's the quality modeling, which focuses on providing an accurate estimate of the client-side quality as perceived by the end user, and this based on the measurable quality of service parameters. Next, there's the quality monitoring part, in which we monitor this perceived quality and also try to gain understanding of the different factors that influence this quality. If, however, this quality would tend to drop too low, we try to counteract that, and that's what we do in the quality optimization and control part, where we adapt the system parameters accordingly to optimize quality of experience. Now, for more traditional multimedia, such as two-dimensional video, for example, this loop is already more or less enabled. Think about the adaptive streaming paradigm we all know. Now, in order to enable this loop for more immersive experiences, there are still some key challenges to be addressed. And we identified 4 of them. First of all, there's the need for a standardized subjective testing methodology of immersive experiences, which should take into account the possibility of cyber sickness and also performance, so the ability to perform the task at hand. Next, of course, we should make sure we have real-time lightweight quality models such that the client device can monitor the perceived quality in real time. Third, there is a need for accurate real-time viewport prediction mechanisms such that if we know in which direction a user will be looking, we can free up the resources for the part of the sphere that is not looked at and use them for further quality of experience optimization. This is actually the fourth challenge to be addressed, in which we try to research how we can recreate or enhance content in case that its delivery is delayed. Now I will go over each of them one by one. Let me start by the subjective evaluations. So for subjective evaluation, there are actually two key challenges. First of all, for the visual part, it is the fact that the user gaze is unknown. Imagine that you have two users, which each give a subjective score for the video. It can be that each of them has been watching a different portion of the video the whole time. If we afterwards average these scores to get a general image of the perceived video quality, this actually doesn't make a lot of sense. Second, there's also the fact that there are, for the user, the combinations of the sensorial data are rather complex. What do I mean by that? Well, either you should ask the user to give a score for each of the sensory channels separately, so for the visuals, for the sound, and for the haptics. But of course, it becomes rather distracting for the user, as he has still to focus on the application at hand as well. On the other hand, you can also choose to let the user give one overarching score for the three sensory channels, but then of course we don't know which of the inputs actually influenced the end user quality well or not. So as a matter of fact, mean opinion scores become insufficient for this kind of applications. And for that reason, we decided to look at it from another perspective. Imagine the example over here, in which a remote operator is controlling a robot arm in a factory by means of haptic actions, and where he or she gets motion feedback back over the network, in addition to augmented or virtual reality video streaming. This could be, for example, to now and then pick up an object to see whether it was actually well manufactured. Now, the key here is not the video quality or the quality of the haptics for the end user as such, but more whether or not the user is able to perform the task. So we're talking about how long does it take for the operator to analyze the object, how many attempts are needed to pick up the object, things like that. And in addition, is the operator not feeling any kind of cyber sickness, such that he can keep on doing the task he is assigned to. So for that reason, we actually propose to work with some kind of overall perception index, which should include the performance, which we define as the ability to perform a certain task within a reasonable amount of time, and also well-being, which we define as the opposite of cyber sickness, where cyber sickness, of course, is the physical discomfort resulting from use of the immersive system. In addition, we can also still include the traditional mean opinion scores we all know to further enhance this perception index. Which brings me to the second part of my presentation, which is the objective modeling. And we are actually proposing a three-phase approach to this extent. First of all, a quality of service, quality of experience analysis on the server side, which should reveal the quality of service parameters or features of highest influence on both performance and well-being. Second, the establishment of a highly accurate objective benchmark that mimics the subjective end-user perception without the actual intervention of a test subject. And then, of course, we try to relate the former to the latter by training and validating a model, which we can then send over the network to the end-user device, where it can be used for real-time, lightweight quality of experience assessment. The third challenge that we have identified is viewport prediction. And you can actually distinguish between two types of viewport prediction. First of all, there's the content-based prediction, which aims at characterizing the given content in terms of saliency maps, motion detection, regions of interest, and so on, in order to estimate the probability of a generic user looking at a particular part of the video content at a given time instant. Second, there's the content agnostic way of predicting the viewport, and in this way we use the user's historical movement as well as the movement of other users that have experienced the same content in order to make a prediction. Now, as both of these techniques have their pros and cons, we are actually proposing a hybrid approach for immersive systems. And in this approach, we would start with a content-aware solution, from which we would extract saliency maps and motion detection for the visual part of the experience. And in addition, we would also extract triggers from the audio and the haptics, because it's not unthinkable that if a user hears something passing by or feels a touch on his shoulder, that he or she will tend to look in that particular direction. And this should result in the creation of what we call multimodal regions of interest. Now, of course, the chances are high that there will be more than one region of interest for a given content. As such, we should also implement some kind of user clustering mechanism such that we can predict at which of the regions of interest a user will be looking. And once we have done this, of course, we can per cluster further apply a content agnostic approach in order to further fine-tune the viewport prediction. Now, this brings me to the fourth and last part of my presentation, which is about the quality of experience optimization. And I will here mainly talk about the content recreation part. We need this content recreation part in case one of the sensory feed packages still arrives late. And in this case, we would actually need some kind of automatic reasoning algorithm, which should decide whether or not it's feasible to wait for the delayed content. If yes, of course, there's no problem. We just wait for the future content to arrive. If not, we should actually need some kind of generator that can predict this future content based on the content we have already seen. Of course, in case this is about the visual channel, we can also feed the viewport prediction into this to know which part of the hemisphere we should actually predict. Now, this generator can use rather easy interpolation methods, but nowadays there are also some machine learning techniques which are gaining attention for this kind of task. In particular, generative adversarial networks, or GANs, are specifically tailored for this kind of task. Now, a GAN is actually a combination of convolutional neural networks consisting of a generator and a discriminator. Hereby, the task of the discriminator is to learn the difference between original and artificially generated content, or put more easily, to distinguish between real and fake, while the generator tries to generate content such that it becomes indistinguishable from its real counterparts. As such, the ongoing competition between those two networks has the potential to deliver rather high quality results, and therefore we think that this kind of networks is an interesting research direction. And this brings me actually to the end of my presentation, so let me quickly wrap up the 4 key challenges and the solutions we have proposed. First of all, there's a lack of a standardized subjective testing methodology, for which we propose a solution with an overall perception index that should include performance and well-being. Next, we need real-time lightweight quality models for immersive experiences, for which we have proposed a 3-phase approach. So a correlation analysis between the QoS and the QoE, a benchmark calculation, and then a modeling phase in which we relate the former to the latter. Third, there is a need for accurate real-time viewport prediction, for which we have proposed a hybrid approach, consisting of a content-based and a content-agnostic part combined with a user clustering algorithm. And fourth, there's also the need for proactive quality optimization and especially content recreation, for which we use or which we propose the use of Ghent. As so far my presentation, I would like to thank you for your attention, and of course if there are any questions, don't hesitate to ask them either in the Q&A or by sending them by mail or even over LinkedIn if you prefer so. Thank you very much.